Hello, my name is Mel, and the following presentation will explore the fundamental concept of binary numbers, their crucial role in computing and how data is represented in binary form and the applications in modern technology. We will cover foundational principles, data encoding, arithmetic, and daily uses of binary systems. Today we discuss what binary is, why computers use binary, how data is represented in binary, converting from alphanumeric input to binary arithmetic and operations, and finally, binary's role in everyday technology. In the following section, we will define binary numbers, explore the historical development, understand binary as a two-base numerical system, and compare it with a more fundamental decimal, which is 10, we have 10 fingers, so that's why we call it decimal, okay? It's based on 10 on our hands. Binary numbers use only two digits, 0 and 1, and the concept dates back quite a while. Binary is a numeral system with base 2, where each digit represents an increasing power of 2, unlike decimal system, which uses base 10. This makes binary ideal for representing on and off states. So 1 is usually on and 0 is usually off. Okay? While decimal uses 0 to 9 and base 10, binary uses only 0 and 1 with base 2. This affects how numbers are expressed, calculated with binary being fundamental for machine level operations. The following section explains the physical reasons for using binary in computers, focusing on electrical circuit design, reliability, and computer advantages. Computers rely on electrical circuits that have two stable states, on and off, which naturally correspond to the binary digits 1 and 0. This two-state logic simplifies hardware design. Binary representation reduces complexity and increases reliability because circuits only need to detect two states, minimizing errors caused by signal degradation or noise. Binary enables straightforward implementation of arithmetic and logical operations, making it efficient and robust for processing by digital computers. We will explore how numbers, text, and multimedia data are encoded in binary form for storage and processing in computers. Numbers are stored in sequences of binary digits, each represented powers of 2. This allows computers to perform arithmetic operations directly on binary numbers. Textual data is converted to binary using character encoding systems like ASCII and Unicode, which each character corresponds to specific binary code. Complex data such as images and audio are represented as large binary files composed of binary codes that capture pixel colors, sound frequencies, and other attributes. The following section covers how characters and numbers are translated into binary codes for computer understanding using encoding standards. ASCII and Unicode are standard encoding schemes that assign binary codes to characters, enabling consistent representation across different systems. We will demonstrate how to convert letters and symbols into the equivalent binary codes using encoding tables, clarifying the process. Sample conversions of common words and numerical values into binary will illustrate practical application of character encoding. Exploring how computers perform arithmetic and logical operations on binary numbers using specialized circuits and logic gates. Binary arithmetic follows similar principles to decimal but uses base 2. We will review how fundamental operations are executed in binary. So binary addition adds binary digits using rules similar to decimal addition and carryover. Binary subtraction involves borrowing and subtracting bits similar to decimal subtraction. Binary multiplication uses shifts and additions to multiple binary numbers efficiently, and binary division divides binary numbers using repeated subtraction and shifting techniques. Logic gates such as AND or NOT perform basic operations, okay? Binary operations enable data processing, and some of this I'm going through quickly because I don't want to get bogged down. Data processing, decision making, control flow in computer systems. Okay, so highlighting the central role. I conclude by examining how binary systems underpin everyday devices like computers, smartphones, networks, and data integrity mechanisms. From processors to memory, binary data is fundamental to the operation of modern computers, smartphones, managing everything from apps to communications. Data transmitted over networks is encoded in binary, providing reliable communication protocols and data transfer between devices worldwide. Binary encoding schemes incorporate error detection and correction techniques such as parity bits and checksums to maintain data integrity during transmission and storage. Binary is the foundation language of computing. So if you remember, 1 is on for circuits or 1 is on for a particular chip and 0 is off. Binary is the foundational language of computing, enabling representation, processing and transmission of all digital data. Understanding binary principles helps us appreciate the technology empowering our digital world. Thank you.